Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a commentary on an article written by Beck, in which he explains what he means by test-driven development. And there are a few surprises there. So let's look into what Beck is saying, and also let's compare this with some other approaches that I've seen, and in particular with Robert C. Martin's 3 rules of test-driven development. So Beck wrote this and published it on 11th of December 2023. At the time of this recording, this is a few days ago, so it's quite fresh, but it's been very interesting to read through it because it breaks a few things that we think about, or I think about when I think about test-driven development. The article is called Canon TDD. In my recent round of TDD clarifications, one surprising experience is that folks out there don't agree on the definition of TDD. I made it as clear as possible in my book. I thought it was clear. Nope, my bad. If you are doing something different than the following workflow and it works for you, congratulations. It's not TDD, but who cares? There's no gold star for following these steps exactly. If you plan on critiquing TDD and you're not critiquing the following workflow, then you are critiquing a straw man. I try to be positive and constructive as a habit. By necessity, this post is going to be concise and negative. People get this wrong. Here's the actual thing. I don't mean to critique someone's workflow, but sharpen their understanding of Canon TDD. Test-driven development is a programming workflow. A programmer needs to change the behavior of a system, which may be empty just now. TDD is intended to help the programmer create a new state of the system where everything that used to work still works, so avoid regressions. The new behavior works as is expected, so the new feature actually works without, let's say, obvious bugs. You might have some non-obvious bugs. The system is ready for the next change. Now, this is interesting because the system is ready for the next change. From my experience, sometimes you find this out when trying to write the next test and not during the refactoring phase. But okay, let's go through it. The programmer and their colleagues feel confident in the above points. So, and confidence is a very important part of test-driven development. We have to be confident that our tests are actually good and testing what they are supposed to. The first misunderstanding is that folks seems to lump all design together. There are 2 flavors: how a particular piece of behavior is invoked, how the system implements that behavior. When I was in school, we called these logical and physical design and were told never to mix the 2, but nobody ever explained how. I had to figure that out later. The steps. People are lousy computers. What follows looks like a computer program, but it's not. It's written this way, not attempt to communicate effectively with people who are used to working with programs. I say attempt because, as noted above, people seem prone to saying, TDD sucks, dude, I did something else entirely and it failed. I've seen this so often. So often I've seen that. And I think one of the key things for me was when I looked into a book called Development Driven Tests or something like that, which was trying to make the point that TDD is failing and we need to write tests in a different way. But the first example in that book was with tests that were checking only the error case and showing that this is bad. Of course it's bad. And that's basically a straw man. I mean, we can critique TDD, but first, in order to critique TDD, I'd rather have a very strong example of TDD working and critique that one. Don't try to use it for things like, it doesn't work for very specific things, or it doesn't work for, we know it has limitations, of course. Of course it does. So don't focus on those, instead focus on the strong points and let's see how we can make them better. That would be a great approach. And now here's what's interesting. So he has a list of steps, and basically there are 5 steps. Step 1, write a list of the test scenarios you want to cover. Step 2, turn exactly one item on the list into an actual concrete runnable test. 3, change the code to make the test and all previous tests pass. 4, optionally refactor to improve the implementation design. 5, until the list is empty, go back to number 2. Number 2 being turn exactly one item on the list into an actual concrete runnable test. And this is where I kind of have a problem. Actually, from the very first step, I have advised people, and we've actually practiced writing a list of the test scenarios. It's a process that I call behavior slicing, because we are taking pieces of functionality and express them in a specific way, like with inputs, action, and outputs. And this works fairly fine, but to me this list is not the end all of everything that I want to do. I would start such a list, or if you are more experienced, imagine it. You can imagine it. And I've actually seen many people who are very experienced who are doing this in their head. At the same time, this list is not fixed. You can move between the items. You can add more items. You can remove some of them because you solve one with a previous test, and so on. So I'm not so certain that having the list and going strictly through the list is the only way of doing test-driven development. I understand that this is his definition, but I'm not sure I fully agree with it. I would call what I do test-driven development, even if I don't have a list that I keep going to and keep returning to and just use that list for everything, Sometimes we switch to jazz, right? We improvise. The initial step. So now let's talk through the steps and what he's telling us about each of them. Number 1, test list. The initial step in TDD, given a system and the desired change in behavior, is to list all the expected variants in the new behavior. There's the basic case, and then what if this service times out, and what if the key is in the database yet, and this is analysis, but behavioral analysis. You are thinking of all the different cases in which the behavior change should work. If you think of ways the behavior change shouldn't break existing behavior, throw that in there too. Mixing in implementation design decisions, chill. There will be plenty of time to decide how the internals will look later. You'll do a better job of listing tests if that's all you concentrate on. If you need an implementation sketch in Sharpie on a napkin, go ahead, but you might not really need it. Experiment. Folk seems to have missed this step in the book. TDD just launches into coding. You'll never know when you're done. Nope. All right, so maybe that's a good point. When do you know when you're done if you're doing my style of TDD? Well, we have acceptance tests, and we can tell when those are passing, right? When the feature is doing close to 100% of what it's supposed to do. I actually find it much harder to figure out from the beginning everything that you need to change. I can figure out the big things and maybe split them into smaller things, but I don't really want to write a full list. So it's a good practice, I think, if you're beginning with test-driven development. But I also think it's something that you'll quickly move aside once you have enough experience with TDD and you start to kind of see what are the next steps and how you know when you are done. When you can answer these two questions, it doesn't really matter. This list is not necessary. But it's a really good practice to do if you start with test-driven development. So don't skip it, don't skim it, actually do this, write this list. It's very helpful. I noticed this with people, and he's mentioning behavioral analysis. Yes, this is about, it's not about design, it's not about implementation, it's about behaviors. It's about what happens when this input comes, what happens with the output. When this event happens, what do we do? These are the things that you need to decide. And if you take these two categories, write them down. If you do this in production, clarify them with a business analyst, your product owner, whomever can answer your questions. And that's it. You have to really do this in the beginning. But I won't hold you responsible. I won't hold you as not doing TDD if you don't write this list later on. Okay. Write a test. Step 2. One test, a really truly automated test with setup and invocation and assertions. Pro tip, trying working backwards from the assertions sometime. It's quite an interesting practice and really useful to work back from the assertion. It's in the writing of this test that you'll begin making design decisions, but they are primarily interface decisions. Some implementation decisions may leak through, but you'll get better at avoiding this over time. Mistake, write tests without assertions just to get code coverage. I've heard about a team somewhere in India who had 100% coverage, lots of tests, no asserts. This is just shooting yourself in the foot. It gives you a false sense of security without actually having that security. So just don't do it. Mistake, convert all the items on the test list into concrete tests, then make them pass one at a time. What happens when making the first test pass causes you to reconsider a decision that affects all those speculative tests. Rework. What happens when you get to test number 6 and you haven't seen anything passed yet? Depression and or boredom. Indeed. I haven't actually seen this, but I think people are doing this occasionally, which is to write multiple tests at once. Just don't do that. Even if you have ChatGPT generate them for you, don't do that. The key here is to write one test, make it pass, refactor. Next test, make it pass, refactor. Picking the next test is an important skill and one that only comes with experience, indeed. I think you can figure this out. I found roughly a few heuristics for picking the next tests. One of them is pick another test that only introduce maximum one new notion at a time. But then the weird stuff is how you define notion. It turns out that programmers have quite a good intuitive grasp of notion, of what a notion means. So I haven't had any problems with this explanation, even though it's kind of a circular definition. But it quite works. So if you need to add a new notion for the next test, maybe pick one that doesn't require you to add a new notion and rather expands the existing ones, more or less. This is one of the heuristics. And then there are a bunch of patterns. One of them is 1 to 3 many. When you start, or actually 0, 1, 2 many. When you start with, when you have a sequence of some sort, first start with 0 elements, then with 1, then with 2, then go to many. And this is a particular form of triangulation, which you can find out more about. So there are a few things you can do. And there are heuristics you can find. Robert Martin also has a list of criteria for this. He calls them the transformation priority premise. And I won't go into details. Let me know if you want a commentary on the transformation priority premise. I think they are quite good, but I also think they are a bit difficult to apply. So, yeah. Instead, I would focus on this. Like, this is a pretty good heuristics. Pick the test that doesn't require you to add another notion, or if it does, only adds one single notion. The order of the test can significantly affect both the experience of programming and the final result. Open question: is code sensitive to initial conditions? Well, I can tell you from my experience with code retreats and solving problems with TDD within various constraints that the code structure is sensitive to the style of TDD that you use and to the constraints that you apply. In reality, if you're doing this in production, you probably won't use constraints consciously, but what you have is biases, and those programming biases and design biases will focus your design. This is why if you give the same problem to 2 different people and ask them to implement it using test-driven development, they might come up with very different solutions. Some of the solutions being equally simple. So it's interesting. It's very interesting to experiment with that. Number 3, make it pass. Now that you have a failing test, change the system so the test passes. Mistake: delete assertions so the test pretends to pass. Make it pass for real. Mistake: copying actual computed values and pasting them into the expected values of the test. Dead if is double checking, which creates much of the validation value of TDD. Now, one thing I'm wondering here is whether this goes against the style of test-driven development using approval tests. In case you don't know, approval tests is a style in which you write a test. The test, instead of having asserts, has something like approvals.approve. And the first time when you run the test, it shows you a diff, and it gives you a difference between the actual result and the one that you have saved. And since the first time you have nothing saved, it will just show you what is the current result. And then you have to click either approve or don't approve. If you approve, that result is stored, and you can, the next time you run the test, it will read it from the file system and compare it. Basically, more or less. There are much more things here. Now, this technique with approval testing, I find it extremely useful for legacy code, which is very different from test-driven development. So test-driven development is about adding new features, adding new behaviors. when you have to write tests on existing code, many people confuse this with TDD, but it's not the same thing. Writing tests on existing code requires a completely different set of skills. Well, maybe not completely. You still need to know how to write the tests, but it requires you to also figure out where to write the tests, how to make this as effective as possible, how to refactor and all that jazz, and how to prepare your code for testability, for allowing you to write automated tests on the existing code, which was not written with tests in mind. So there's a bunch of things there, and approval tests really help with writing these characterization tests. So you would call things from your system and then store the result. And basically, if you're doing this a long enough time or with a large enough value set, one way to do that would be to generate values or to iterate. If you have as input a bunch of a date, you can use this with a bunch of dates, like pick 100 dates from various years and various periods of the year. And in doing so, you end up with tests that are checking your existing system and that are storing the current behavior and kind of fixing the current behavior of the system. But in this case, you don't want to know what the current behavior is more than we have tests that cover it and it works. Because your next step will be to start refactoring. And you need the tests in order to be able to start refactoring. So this is, but the approval tests has evolved into a style of test-driven development. And some people find it easier, but to me it looks like, well, approval test has a kind of double checking in the sense that you look at the value and you think, does this actually match what I'm expecting? But on the other hand, by not having the value explicitly computed in your mind before, it's a lesser style of double checking. It's not as much. So I'm not so sure. I'm kind of torn here. The thing is, me in particular, I find approval tests very useful for legacy code. I have seen it used for test-driven development. I don't find it as useful as the other way, or other ways like data-driven tests or property-based tests. I find those much more useful than this style. But there's just a personal preference. So if you are using approval tests, props to you. You found something that works, fine. No worries. Mistake, mixing refactoring into making the test pass. Again with the wearing two hats problem. Make it run, then make it right. Your brain will eventually thank you. Yeah, I absolutely agree here. Make the test pass first. And if you need to duplicate some code, do it. If you need to add some weird lines of code, do it. If you need to add things like if I equals 0, then do this, do it. Just do the simplest implementation you can think of. Although it doesn't say this, I find this interesting as an omission. Usually the rule here was to write the simplest implementation that you can find, but it turns out that Ken Beck is not so keen on this rule. But he is focusing on make it run, then make it right, which is absolutely the right way. If in the process of going red to green you discover the need for a new test, add it to the test list. If that test invalidates the work you've done already, oh no, there's no way to handle the case of an empty folder, you need to decide whether to push on or start over. Pro tip, start over, but pick a different order to implement the tests. This is where going from simple to complicated will solve a lot of problems. And going from a notion, as I was saying, add a new notion at a time and only one. A rule can help you a lot. Okay, because you will order the tests more or less based on complexity, based on new complexity that you are adding and just going into small steps. And it's less likely that you'll need to go back. To be honest, if that test invalidates the work you've done already, you need to decide whether to push on or start over. It will be very hard for people to start over, although it is in many cases the right call. So honestly, don't be afraid to start over. Most likely it will save you a lot of time, because otherwise you need to refactor some of the existing code and maybe some of the tests, particularly if you haven't written the tests in such a way that you can change them easily. But honestly, I have another issue here, which is I do another thing which I think is very useful. I'm writing a new test, and then the test fails. I'm running it, it's red. So I have only one failing test. And now I'm looking at how to make it pass. And I realize, oh, if I only did a bit of refactoring, then this test will pass much more easily. So in that case, what I do is I comment out the last test, go back to a green state. So now I have a green state, but a commented test, which is bad practice. So don't do it unless it's for a very short time and with a very good reason, which it is in this time. And then I go back into refactoring. And then I re-enable that test. You might want to disable it instead of comment. Whatever works for you. Doesn't matter. Re-enable that test. One test that fails, go and implement, because now implementation is easy, and move forward. I find this is a very simple way of just, and I call it making space in the design for the next behavior. And honestly, I don't see any reason why you won't do that. It's still a discipline. You still need to be very disciplined when doing this. But there's really no reason to stop you from temporarily, very important, temporarily disabling one test to make things work again. Particularly if it's the test that introduced a new behavior, so then why not? All right. Number 4, optionally refactor. Now you get to make implementation design decisions. Mistake, refactoring further than necessary for this session. It feels good to tidy stuff up. It can feel scary to face the next test, especially if it's one you don't know how to get to pass. I'm stuck on this on a side project right now. Mistake, abstracting too soon. Duplication is a hint, not a command. I really like this. Too often we jump into removing duplication, and honestly, you don't always need it. It's not 100% necessary to do that. Number 5, until the test list is empty, go to 2, seems self-explanatory to me. Okay. So that's an interesting list. And I think it makes sense. And I think it's something that I agree with 90%. And the rest of 10% comes from experience, and perhaps a different experience than Kent Beck's. So I told you some of the things that I would do differently. I don't think there's absolutely a need for a list. I think you can do just fine without one, but it doesn't hurt having a list as long as you don't just, kind of stick to it and don't iterate even on that list. I wonder why he introduced this. I think probably there were cases in which people didn't know when to stop or something like that. Although I think there's probably something different. He must have seen some weird stuff. And the second thing is about sometimes if a new test is difficult to implement, you can write the test, but it's difficult to implement the code for it. Disable it, refactor a little bit more, re-enable it, and keep going. No reason to delete everything and start from scratch in this case. Yeah. So honestly, there's this tension in test-driven development between... So what we are doing is basically exploring a design space, a solution space, and we start here and we know that we want to get here, but we don't know which way we will take. And there are tens, if not thousands, of ways of getting from where we are to where we want to end. And I don't see any problem with kind of going and then turning a little bit back and then going further and going a little bit back and so on. I don't think the only way is to come here and if you get stuck, jump straight to the beginning. If you get stuck, jump straight to the beginning and then focus on having a perfect flow. Because the focus should be on reaching the end. And if you can do it, you should just be able to go back. And one way of doing that is by committing after each green test. After every test passes, commit. And then if you really get stuck, you can kind of go back 2 steps, 3 steps, and so on. Of course, if you've only written 4 or 5 tests and then you figure out how we are missing a really obvious thing and it's very difficult to add, rewrite, throw everything away, and it's not going to be that difficult to do it again. The first time is probably longer. If you try to do it the second time, it's going to be much faster. So these are my opinions regarding to this and what I would change. Now let's compare this with another very common, more or less, definition of test-driven development coming from Robert C. Martin. Over the years, I have come to describe test-driven development in terms of 3 simple rules. They are: 1, you are not allowed to write any production code unless it is to make a failing unit test pass. And yeah, I think Kent Beck's description covers this. Number 2, you are not allowed to write any more of a unit test that is sufficient to fail, and compilation failures are failures. Now this is where he diverges from Kent Beck's number 2, which is write a test, one test, a really truly automated test with setup and invocation and assertions. It's in the writing of this test that you'll begin making design decisions, but they are primarily interface decisions. Some implementation decision may leak through, but you'll get better at avoiding this over time. So it seems they come at a head here, because another way of doing test-driven development is, let's say I need a new class. So I would write in my test before the class exists. Let's say I need the class patient list or user list, patient list. Let's stick to patient list. I've been doing some work in eHealth, so it's an example that comes easy for me. And I would say, okay, so I can have a patient list with 0 elements, and if I will ask it the number of elements, it will tell me 0. Okay, so how do I test this? I would write patient list equals new patient list. And now here's where the next step is a slightly different change in style. So one style is, particularly if you're using Java or C#, any kind of compile language, you would say, oh, so now this test doesn't compile. So the first thing I need to do right now is to create the class patient list. And typically, if you are in one of these languages, you can hit a keyboard shortcut that will automatically create the class for you. In Visual Studio or in IntelliJ IDEA, you have this option. All right, so now the test compiles, and now I can go forward and say assert patient list dot count equals 0. Okay, now what's missing? We don't have the count method. So I can create the count method first, and now the test compiles. But I've had, if you take compilation failure as failure, basically you've had two failures until now on the same test, and presumably a third one when you run the test and it doesn't return 0. Although it will probably return 0 with the automated implementation, if it's a Mint. And then you run the test on, you make the change in the code and you run the test and you see it passing. Okay, so which one is the right one? Because the second style would be, I'm going to write the whole test. Patient list equals new patient list, assert patient list dot count equals 0. Now if I try to run the test, I get compilation errors. Okay, so I'm gonna start creating, okay, patient list and then count, and now I'm having a test that passes. Well, that fails. First, I can make the change. I get a test that passes. So honestly, it doesn't really matter, because it's really a matter of style. One thing about this method that goes into smaller steps is that you focus on one thing at a time. First, you make things compile, and that gives you, dopamine boost. I made something. I did something work slightly better. So that works, now that works, and now that doesn't work, but now I make this change and now it works. Perfectly fine. So it doesn't matter to me which one you are using, but the key here is to end up with, as Ken Beck is saying, a really truly automated test with setup and invocation and assertions. So have all of the three things. very important. Particularly, most important assertion. The other ones might be necessary as well. The third law of TDD, as Robert C. Martin presents it, you are not allowed to write any more production code that is sufficient to pass the one failing unit test. And this is quite interesting, and I think it's not touched here. Yeah. So basically in step 3, can't Beck, step 3, make it pass, Ken Beck says, now that you have a failing test, change the system so the test passes. So there's no mention that you just add the code to make this test pass. But I think it's a necessary condition, because if you add more code, you end up with code that it's likely not tested. And this can get you in trouble later on. So I think I would change here on number 3, make it pass, and add a little bit more context. A little bit more context is needed. Just writing. And this is also one of the reasons why we are saying implement the simplest possible code to make the test pass. And then during the refactoring step, you figure out how to remove some of the duplication that comes up and so on. Now, if you want me to showcase these different styles, I'm actually considering doing various styles of TDD. There's also classification of TDD that you can use, because if you think you know test-driven development, it might happen that you just know one style. But in reality, you can do outside-in test-driven development, you can do inside-out, you can do data-focused or behavior-focused. Then it matters what types of tests you are writing, because you can mix in various types of tests. It matters what kinds of test doubles you are using, and so on and so forth. There are really probably 20, 30 different styles with a lot of variations. And these are very interesting, but really they are interesting on an intellectual level, and I need to know if you are interested in learning more about them and seeing them in action. Because to me that would be fun to do, but I also need to know that at least somebody will be watching this kind of videos. So what do you think about this definition and about the 3 laws of TDD? Is test-driven development something that you've used, or something that you plan to use, or something that seems to you like a complete waste of time, and why? Let us know in the comments. And until next time, thank you kindly for the view, and remember to think, design, and work smart.